Alright, hi guys, welcome to BGSS Science Physics. Okay, today in this video we're going to go through a revision basically on chapter 1 to 5. Okay, and part of it I have already went through in class, so just in case your notes is different from mine, okay, this was written on a whiteboard. Okay, so if you haven't done so, please copy it from your friend. Otherwise, this was what we went through all the way to this point on kinematics. Okay, so if you need help with kinematics, do let me know. Okay, but in any case, let me just re-illustrate again how to tackle this question. First, when we want to calculate acceleration, right? Okay, we have the speed time graph. Okay, and we can actually deduce from the gradient from a speed time graph the acceleration. Now, what you would like to ask yourself then is, at this point there is no acceleration, okay, because speed is constant. Okay, so if we were to look, right, at 10 seconds the speed is 20, at somewhere about 15 seconds the speed is still 20, you know, and finally at 20 seconds the speed is also 20. So if the speed remains at 20 for a whole 10 seconds, in other words, speed is constant, and where speed is constant there is no acceleration. Alright, so when they say calculate the acceleration, they are obviously only asking from the 0 second to the 10 second. Okay, so in that case we have this statement here, only accelerating from 0 to 10, and the rise over run is simply 20 over 10. Okay, remember that average speed is total distance over total time. Okay, and I think we are done here. Okay, now for force, I would like to make a very clear distinction between speed and acceleration at this point of time. So let me just open up a blank sheet. Okay, give me a second. I think this should be able to, this will do. Hold on. Here. And this will do. Okay, so we have the idea of speed, okay, or velocity. Now in your syllabus, the only difference is the direction, and most of the time the questions won't be direction based, so don't worry. Okay, these two terms can be used in the question almost interchangeably. Now, what is speed and what is velocity? So let's imagine I have a car. I have a, say, a box. Okay, a box that is traveling from point A all the way to point B, and you know that point A to point B is 10 meters. Alright, so if this thing travels from A to B, okay, in 1 second, you know that the speed is 10 meters per second. That's because it covered 10 meters in 1 second. However, if it traveled up to this point, we call this point C. I'll use a different ink, and from A to C it is 5 meters. Okay, and it traveled here in 1 second, we call the speed 5 meters per second, because in 1 second it was only able to travel a total distance of 5 meters. Okay, so that's the idea of speed. Now please do not confuse yourself between speed and acceleration, because as you have mentioned in class, what is acceleration? Okay, so if I have a box that's moving here, okay, and in 1 second it moved 2 meters, right? But in the next 1 second it actually moved more than 2 meters. It actually moved from this point here to this point here. Okay, so let's assume that this is 4 meters and it is also in 1 second. So you realize that the speed changes, right? So over here the speed equals to 2 meters per second, but over here the speed was 4 meters per second. So you realize that the speed is not constant. Now when the speed is not constant, we say that there is an acceleration. So in this case, right, the acceleration is actually 2 meters per second square. You can note the SI unit. Alright, now the idea of 2 meters per second square would then therefore mean that at 1 second, so we have a time and speed chart. Okay, in 1 second, the speed may be 2 meters per second. Okay, at the second, okay, the speed will be 4 meters per second. Alright, and at the third second, the speed will be 6 meters per second. Alright, so you realize that increase by 2 here and increase by 2 here. Okay, so that is the idea of acceleration, and please, I want you all to understand the main difference between speed and acceleration, because some of you are confused between these two. Okay, now we come back here. Okay, the idea why we need to understand what is speed or acceleration is because we are dealing with forces, and here we are. We have Newton's first law saying that when a car is traveling at a constant speed, okay, constant speed will therefore mean that there is zero acceleration. Alright, that means the car can be traveling at 60 km per hour for 1 hour. For 1 full hour, it's traveling at 60 km per hour. We say that that's a constant speed. Alright, of course, the question may call it constant velocity as well. Okay, now when this happens, please know that F net equals 0 or resultant force equals 0. Okay, they are the same statement. Alright, Newton's second law states that when a car is accelerating, F net equals to ma. Okay, or F net equals to ma, or resultant force equals to ma. And of course, a here means acceleration. Okay, and m here means mass. Alright, now please also note this: resultant force equals to F applied minus F opposing. Most of the time, this is friction, most of the time. Alright, and if you look at this free body diagram here, you should be able to understand what I'm doing. Okay, in fact, one of the earliest example we did in class was something like this, and you kind of intuitively know that F net equals to 2 Newton. Alright, now the next part, we deal with drawing free body diagram. So know that friction, okay, always acts on floor and on body. It acts on the floor and it acts on the body. Okay, so it starts here and it's along the floor. Alright, the push pushes the box, so it has to be out of the box. Okay, unless we are talking about weight. Weight comes down from the box. Alright, so some of you all draw weight as this. This is wrong. Okay, some of you all draw it here also. This is wrong. Alright, because it comes down from the center of gravity. Now, air resistance is upwards. Okay, air resistance is a force. It's another type of opposing force. Alright, so let me write it here. Okay, so next, let's go through this example quickly. Now, when you look at this example, please read carefully. Okay, a car of mass 250 kg. So this is the mass. So you may want to write m equals to 250 kg. Okay, traveling at constant speed. So constant speed means a equals to 0. Now, what is this 10 meters per second? This is speed. So speed equals to 10. When I mark your workbook, some of y'all took a as 10. Okay, when you see the word 10 meters per second. Okay, please don't assume all numbers are just whatever values you're going to use later. Okay, so constant speed of 10 meters per second. So what is the resultant force? Now we look at Newton's first law. It says that when a car is traveling, sorry, can you change this? It's not just a car. When an object, okay, so it need not be a car, it can be a box. When an object is traveling at a constant speed of 5 meters per second. Okay, please erase this as well. This is just an example. Alright, so when an object is traveling at constant speed, resultant force is 0 Newton. Okay, so is this object traveling at constant speed? Yes, so F net equals to 0 Newton. Because constant speed also refers to A equals to 0. Right? What is the frictional force acting on a car? So we just need to draw the free body diagram. The driving force is 1000 Newton. The friction acts on the floor. If F net is 0, then the blue arrow and the black arrow must give you 0. So 1000 minus friction equals 0, right? So friction must be 1000. Alright? Now, they change the question such that the driving force increases to 2000 Newton. Now find the acceleration. So Redraw the free body diagram, assuming that the frictional force remains unchanged. That means the frictional force is 1000 Newton. Redraw it and you'll get something like this. This is the friction. Okay, this is the new driving force. So from here, we actually know that F net equals to 1000 Newton and 1000 equals to MA. So just do this working. F equals to MA. Find your A because F net is 1000. You get 4 meter per second squared. Okay, this is your answer. Alright, now we come on to page 4, in which we deal with mass, weight, and density and moments. Okay, so we're near the end. Sorry, just give me a moment. Okay, now, let's continue with chapter 4. W equals to mg, and the SI unit for W is Newton. In other words, weight is a force, and of course this is mass, and G is gravitational field strength. Alright, and density equals to mass over volume. Okay, the SI unit can be either gram per cm cube or kg per meter cube. Okay, so please take note what SI unit they want. Sometimes they will want this, sometimes they will want this. If they want gram per cm cube, make sure your volume is equals to something cm times something cm times something cm for the case of a cube or cuboid. And of course, if it's a meter cube, okay, your volume will therefore be equals to something meter times something meter times something meter. Okay, maybe 3, 4, 5, and this maybe 2, 3, 4. Okay, something like that. Alright, and of course, please take note that your mass must be in kg or gram accordingly. Okay, we did the conversion earlier on the first page, somewhere around here. Yes, here. Okay, so if you have issues still, do let me know. Okay, now we do an example, and then we should be done with this question. Given that the weight of the box, volume 1 meter cube. Okay, so V equals to 1 meter cube. It's 800 Newton on Earth, so W equals to 800 Newton. Okay, not mass, alright, but W. Find the mass, given that the gravitational acceleration is 10. So W equals to mg. Your weight is 800. M is unknown. In fact, that's what they want you to find. And G is 10. Now, in this case, M will therefore be 80 kg. Alright, so part 1 done. Part 2, find the density of the box. So we have density equals to mass over volume, which is equals to 80 kg over 1 meter cube. Okay, so it will be a good thing to learn to write this here, okay, so that you won't be confused of the sign in the SI unit, not sign, sorry. So in this case, the SI unit that you are interested in will be therefore in kg per meter cube. Alright, and lastly, find the weight of the object on the moon. Now, W on the moon, weight on the moon, will therefore be the mass, which is a constant. Remember that mass is constant. Okay, times the G on the moon, and this will give us 80 times 1.6. Okay, let me press my calculator, and 80 times 1.6, you get 128 Newton, right? And yeah, this will be it for chapter 4. And last part, moments. Okay, moments equals to force times perpendicular distance. Alright, and the SI unit is Newton meter. The principle of moment states that the sum of clockwise moment equals to the sum of anti-clockwise moment. Alright, and looking at this example, because of the word sum, first we need to identify, does this force cause a clockwise or anti-clockwise moment. So we identify each of the three, and I'm going to use a different color for each of them. Okay, So for W1, I'll use blue. Okay, how do I know is it a clockwise or anti-clockwise moment? I'll follow the arrow, identify the pivot. Okay, this is the pivot. Okay, and I'll draw the arrow. I'll link the arrow all the way to the pivot. So in this manner, in this manner. Okay, the arrow direction persists, and you realize that this is actually anti-clockwise. All right, for W2, we use red. Okay, same thing. Connect it to the pivot, and you realize this is anti-clockwise as well. For the last one, I'll be using black. Okay, W3, I'll connect it to the arrow. The only way I can do this is in this manner, and this is in clockwise. All right, so W3 is clockwise, while W2 and W1, they are in anti-clockwise. Alright, so using this statement here, sum of clockwise moment equals sum of anti-clockwise moment, we know that W1 times the distance from the force all the way to the pivot, which is D1 plus D2, plus W2 times D2 must be equal to W3 times D3. Okay, so note that this distance here, we are actually talking about the distance from the force to the pivot. Alright, okay, now lastly, just a few definition question. The center of gravity is the point where the weight of the object seems to act upon. Alright, and an object is stable if it has a wide base and a low center of gravity. Okay, so just remember this, a triangle in this manner with the CG here, and a triangle in this manner with a CG here. Okay, this is stable and this is unstable. Alright, and to make it better, a triangle with a CG here and a triangle with a CG here, this is more stable and this is less stable. Alright, so some of y'all may ask, how can my CG, why is CG not in center, right? So let's take a look at this. Alright, we have a triangle that's made of different material. Okay, so this is wood and this is metal. Alright, so metal being heavier, obviously the center of gravity will be lower. Okay, for an object that has the center of gravity in the center, okay, this is probably just made of wood or metal. Okay, it's the same material, so the CG will be lower here. Okay, so lastly, let's deal with two examples. Okay, and then we can end this video. Alright, so calculate F shows a uniform meter rule. Now the idea of a uniform meter rule, meter means 1 meter, right? Now uniform means that the CG is in the middle. Okay, that means the weight is here. Okay, that means this is 50 cm. Alright, first thing first, you need to know W equals to mg. Okay, you can take G as 10. You have 1 times 10. This is an assumption. Okay, usually the question will give you, but in this case, this question doesn't, so you just assume that this experiment is done on Earth, therefore G is 10, and that will give us 10 Newton. Alright, so using the principle of moments, okay, we have using the principle of moment, we have the sum of clockwise moment equals to sum of anti-clockwise moment. Okay, now we need to identify, does F cause a clockwise anti-clockwise moment? So we do the same thing. We're gonna get anti-clockwise. Alright, you do for W, you do the same thing. You're gonna get clockwise. Okay, so W is the clockwise one, and in this case, because this is 50 cm, this must be 25 cm. We have W times 25 equals to let me use a different color, okay? Maybe that will be better. Equals to f times 20. And then let me work out this. You get 250 equals to 20f, and f will therefore be I get 12.5 Newton. Alright. Okay. Why an object returns back to its original position using a diagram and words. Okay, so first we have this cuboid here. Okay, remember what we did in lesson. This is the W, and this is the base area. Okay, so in order for object to fall back, the weight has to be within the base area. Alright, and lastly, why an object topples down. So you may want to draw another diagram. Label this as the base area. Okay, find the CG, which is here, and realize that object falls. Remember to label your object also, A, B, C, D. Object falls on BC when the weight falls out of the base area. Alright, now of course there's another scenario, so let me draw in red, where the object can fall in the opposite direction. Hold on. So you gotta fall. So it will look something like this. So in this case, it will fall on CD. Now the explanation is the same, but be sure to label your diagram. Sorry, I made a mistake. Should be fall on AD. Alright, the explanation is the same, but please make sure you label your box. Okay, so whoever is marking will understand what you're talking about when you say fall, and where is it falling. Is it falling on in this case BC, or is it falling on AD? Alright, and that will be all. Okay, thanks for watching, and I'll end the video here. If you have any questions, do look for me in school. Alright, thank you, bye.